Hello everybody. We're going to start today with geometric sequences and series. It's the exact same idea as yesterday with the arithmetic sequences and series. Same ideas, only from one term to the next you are going to multiply or divide, but I don't really think of it as division. I think of it as multiplication, because if you're dividing, you're going to multiply by a fraction. And yes, you do have to be able to work with the fractions. It's just a little scary when you don't. So make sure that you are ready for this. I mean, remember, multiplying fractions is not that big a deal. Just leave it in fraction form, top times top, bottom times bottom, and reduce. That's all there is to it. I mean, it's not really all that crazy. So let's get started with this. If you look at the sequence that is up there, the 8, 4, 2, 1, obviously those numbers are getting smaller. So that is multiplication by a fraction. So, you can see that as obviously dividing by 2, but I'm going to say we're going to think of that as multiplying by 1/2. So our common ratio for this guy, which we're going to call R, our common ratio is 1/2. It is whatever you are multiplying by to get from one term to the next. All right, so just like last section, we had some formulas. Same idea here. We're going to have some formulas with the geometric sequences. So here's the deal. A sub n is going to equal a sub 1 times r to the n minus 1 power. So that's your formula. A sub n is still the last term, or the term that you're finding or whatever. A sub 1 is the first term. R is your common ratio now, whatever you're multiplying by to get from one term to the next. And then n is the position, again, of that last or given term that you're looking for. All right, so you do need to know that formula. The other formula is the sum. So this applies to a series. Remember, series is adding all of the terms of a sequence. So it's not like, you're doing anything crazy or new, but you're going to add all those terms together. So it's a little bit more complicated than our last series formula. You have S sub n, so you're adding up a certain number of terms in a series, and we're going to take the first term times 1 minus r to the n over 1 minus r. So again, this is going to be a little bit more detailed as far as, putting stuff in your calculator, but most of it can be done that way. All right, so we're going to find this sequence, or we're going to find the 9th term of the geometric sequence that's given here. So we're going to use that formula of a sub n equals a sub 1 times r to the n minus 1 power. I know I had parentheses in the other one. I like the look of this a little bit better. It's not as crazy looking. And really, when you have that multiplication, you don't really need the parentheses that are there. All right, so we're looking for the 9th term of the sequence. So it's a sub 9 that we're looking for. Our n is 9. Our first term is 4. And now we have to figure out how we're going to get from one term to the next. Well, again, this is not really all that difficult. We can kind of see what's happening there. But in general, to get your r, again, like I gave you a method for your d, I'm giving you a method for your r. Instead of taking your second term minus your first term, which is how we got our d, we're going to take our second term over our first term. So we would take 2 divided by 4 and reduce that, and r is 1/2. Okay, so then we're going to put that in as 1/2, and then we're going to raise that to the n minus 1 power. So that's the 9 minus first power. Okay, so again, we have a little bit of math to do here, and the first thing that you should do is not grab your calculator, because you're going to get a gross decimal that I don't want as an answer. Your answer should be in fraction form unless your original has decimals in it. So the 4 comes down. We're going to multiply by 1/2 to the 8th power. Well, 1/2 to the 8th power, again, if you kind of go off here in your little thought cloud, that is 1 to the 8th power over 2 to the 8th power. Really, this is not a big deal. 1 to the 8th power is just 1, and then 2 to the 8th power is, sorry, I didn't have that ready to go, 256. Okay, so that's what you're doing. You're not necessarily writing all that stuff down, but that's what you're doing in your head. This is your thought cloud right here. Okay, and then that's what goes in place in your formula. So that 1 over 256 goes there. Now hopefully, since you know that 256 is 2 to the 8th power and 4 is 2 to the 2nd power, that you're actually going to be able to divide these things nicely. So, you know, throw your 4 over 1 if you need to, reduce the 4 and the 256, and they absolutely do reduce. 4 goes into 256 64 times, and you get 1/64 there. The scariest part of this problem should not be the fact that you have fractions in it. It really shouldn't be a scary problem at all. All right, so moving on. Example 2, write a sequence with two geometric means between 48 and negative 750. This is just fun. All right, so same as before. We have our first term, which is a 48, and then we're going to have two geometric means, so two spots in between there. So they're called geometric means now because it's a geometric sequence instead. And that's what tells you, what your D is going to be if you're going to have a D versus an R. All right, so we have to figure out what R is. So we're going to use that same formula, only we have the A sub n. So negative 750 is our A sub n. That's going to equal our first term times R to the n minus 1. So we have n terms, 4 terms, 48, 2 in between, and then the negative 750. So then we're going to do to the 3rd power. And we're just going to solve this for R. So we're going to first divide both sides by 48. So that gives me negative 750 over 48. Now if you divide that out using your calculator, you're going to get a decimal answer, and you really don't want a decimal answer here because we can get an exact answer. So we're just going to reduce that fraction. Now that fraction reduces all the way down to negative 125 over 8. Now when I see that equal to an R cubed, that makes me happy because I know that 125 is a cube. It's not a perfect cube, we call it perfect square, but it's the cube of an exact number, and then 8 also is. So we're going to take the cube root of both sides, and then this is just beautiful. The cube root of 125 is 5, the cube root of 8 is 2, and it's going to be negative. So my R is negative 5/2. But of course, that's not the end of the problem. I'm going to scoot this guy over. That's not the end of the problem. Grab that 3. So now the rest of my problem is writing out the sequence. So I'm going to start with my 48. My next term is going to be 48 times negative 5/2. So you could do this in your calculator. I, of course, enjoy the mental math part of it all. And this is your thought cloud. You're going to take your 48 times negative 5 over 2. 2 goes into 48, 24 times 5. That's all you're really doing there. And that'll give you your next term, which is negative 120. And then do the same thing. Take my negative 120, sorry, and multiply it by the negative 5/2, and that will give me a positive 300. And then hopefully 300 times negative 5/2 gives me a negative 750. And that makes sure that I got the right R value. If I don't get to that negative 750, then I've done something wrong. Okay, but I like the mental math in each of these things, especially with the division and the fractions and stuff. It's good practice. You should keep it in fraction form. All right, the last example that we are going to do, we're going to do one during class, but this last one we're going to do in here in the notes. We're going to find the sum of the first 10 terms of the geometric series. So again, our formulas are a little bit more complicated, but here's what we want to do. We want to do a little thought cloud off to the side with our R. So we need to know what R is so that we can figure this out. So we're going to take our second term, which is negative 48 over positive 16. That's to get R. And that gives us negative 3 as our R. So again, that's kind of like my little thought cloud, depending on how you want to do that, but I like, again, mental math. All right, so here's my formula. My formula doesn't use my a sub 1 and my a sub n like the other one did, so I don't really need to get that last term. I just use what I have right now. So it's s sub 10, because I'm looking for the first 10 terms, equals my first term times 1 minus. Now you have to be careful in here. We're going to take the negative 3, this is my r, to the 10th power. So I know that that looks ugly right now, and you're very tempted to cancel out those negatives in the middle, but you can't do it because you need to raise the negative 3 to the 10th power before you do your opposite signs. Okay, so we will get to that, but that's not right now. And then in my denominator, it's going to be 1 minus negative 3. Now, of course, that one can turn into a plus sign. All right, so here we go. Big numbers here, 16. And then we're going to have a 1 minus. Now, negative 3 to the 10th power is 59,049. And that's going to be a negative. Is it going to be a negative? No, that's going to be a positive, which means my answers are wrong. So you need to bear with me a little bit here. So it's going to be 1 minus, and then this is a 59,049. That part's right. And then I'm dividing by 1 plus 3, which I will eventually turn into 4. All right, so then I'm going to subtract. I have 1 minus that 59,049. So I'm going to have 16 times negative 59,048. And I'm dividing that by 4. Now I'm going to do something a little bit different here. Normally we would multiply the 16 times that number and then divide by 4. Since 4 goes into 16, and this is all multiplication here, I can cancel that out. So this is, again, good practice with your fractions and knowing what you can do. So 4 and the 16 are going to cancel. So now I'm going to have 4 times that negative 59,048. And then I just multiply those together. And I get negative 236,192. And that's the sum of my first 10 terms of that sequence. Okay, so if I add those together, that's what I'm getting. That's it. That's it for notes right now, and we'll do one other example during class. See you tomorrow.